Hi, in this video I will briefly explain the concept behind hypothesis testing. I will also explain what a p-value is and how and why we use significance level. When you want to do a scientific experiment, you start with a null hypothesis, that there is no relationship between the parameters you want to investigate. And then you formulate an opposite alternative hypothesis, which will be true if the null hypothesis is false. Let's say I want to investigate whether there is a relationship between blood pressure and age. I formulate my null hypothesis. There is no relationship between blood pressure and age. And the alternative hypothesis, there is a relationship between blood pressure and age. The reason for why we do this is something called the falsification principle. And that is that you can't prove that something is true, but you can only prove that something is false. So if you prove that the null hypothesis is false, then you have a proof that the alternative hypothesis is true. So once you have defined your null hypothesis, you can start doing a scientific experiment. So when you do your statistical analysis, you will get a p-value. The p-value is the probability that you get the exact result that you got given that the null hypothesis is true. So if your null hypothesis is true, if there is no relationship between age and blood pressure, then you would probably get a high p-value. If you get a low p-value, the null hypothesis is probably not true. But what should you do with your p-value then? We'll look at that next, but first you need to understand the concept of significance level. The significance level alpha. In medical research, you often use a significance level of 5%, alpha equals 0.05. The significance level is the limit that you set, the maximum probability that you are willing to accept to reject the null hypothesis when it is actually true. So when you have a 5% significance level, there is a 5% risk of concluding that there is a relationship between your parameters when there is no actual relationship. And now over to the relationship between the significance level alpha and your p-value. If your p-value is lower than the significance level, you can reject your null hypothesis. You will say that your p-value is lower than 0.05. In our example, this means that if we get a p-value of 0.04, we can reject the null hypothesis and accept the alternative hypothesis and conclude that there is a relationship between age and blood pressure. Your p-value of 0.04 means that there is only a 4% chance that you get this result if the null hypothesis was actually true. So most likely the null hypothesis is false. However, there is still a 5% risk that the null hypothesis is true, even though you rejected it since your p-value was lower than the significance level. So, to sum up, the significance level alpha is the probability of rejecting the null hypothesis when it is actually true. The p-value is the probability of getting exactly this result given that the null hypothesis is true. I hope this background on hypothesis testing, p-values, and significance level gave you an understanding of how to use and interpret this in statistical analysis later.